Question 7, kinematics. This is a projectiles problem. At time t equals 0, a particle P is projected from the point A, which has position vector 10j, with respect to the fixed origin O at ground level, and the ground is horizontal. The velocity of projection is 3i plus 5j meters per second. And the particle moves freely under gravity, so there's a negative acceleration of minus 9.8 j, and it reaches the ground after t seconds, big T seconds. Okay. Being given the initial velocity as a vector is convenient, as it's already split into the horizontal and vertical components. Part A, we have to show that the position vector r after t seconds is given by this expression: r equals 3t plus 10 plus 5t minus 4.9 t squared j. We consider the horizontal motion. The horizontal displacement x, travelling at a horizontal velocity of 3 after t seconds, will be 3t. The vertical motion, we use s equals ut plus a half at squared. We have to modify this a bit, as this formula assumes that the projection is from the origin. So here we have to write y equals 10 plus ut plus a half at squared, and the initial vertical velocity is 5, so we have 5t. The acceleration is minus g, so we have minus a half gt squared. So this equals 10 plus 5t minus 4.9 t squared. So we can write the initial vector as being r equals the horizontal displacement x, or 3ti, plus the vertical displacement 10 plus 5t minus 4.9 t squared j. We're told that it hits the ground when t equals big T, and the j component is 0. So we set this quadratic equal to 0. We use the formula to calculate its roots, and the only positive root will be big T equals 2.03 seconds. We're then asked to find the velocity at time t. So here, if we have a vector describing the position or displacement at time t, we simply differentiate that with respect to t to get the velocity vector r dot. So r dot is 3i, we differentiate this, we get 5 minus 9.8t j. Then we're told when p is at the point B, the direction of motion of P is 45 degrees below the horizontal. So we could either observe that if it's at 45 degrees below the horizontal, and we know the horizontal component is 3, then the vertical component would need to be minus 3. More generally, we know that the velocity vector would have to be a scalar multiple of lambda I minus j. That will give us an equation which says that this component is equal to minus this component. So the 5.98t equals minus 3. So that tells us that t equals 0.82. At this point in time, the velocity will then be 3i minus 3j, and if we want to know the speed, we have to calculate the magnitude of the velocity, so that's the square root of 3 squared plus 3 squared. So that's root 18, or 3 root 2, which is 4.24 meters per second.